The speed of sound. Sound is used in sonar to determine the distance between an object and the source of the sound. Similarly, if the distance between the object and the source is known, the speed of sound can be calculated using the formula speed is equal to distance between the object and the source and the time taken for the sound to get from the object to the source. We aim in this experiment to determine the speed of sound in air. We expect that the result should be close to the theoretical value, which is 343 meters per second at 20 degrees Celsius.
The purpose of this experiment is to determine the value of the speed of sound in air. To do that, we've got this long 1.5 meter pipe, which is closed at the end here. At the mouth of the pipe, I've got a microphone, and the microphone will pick up the sound. And the sound source that I'm going to use is just that. I'm just going to click my fingers, get a value for sound, and the microphone will pick up the incident sound. It will then travel down the pipe, get reflected, come back, and the microphone will pick up the reflected sound as well. And then we'll work out the time. Once we've got the time and we've got the length of the pipe, which is 1.5 meters, we'll then work out the value for the speed of sound. Now we have to repeat that a couple of times. We'll repeat it about 5 times so that we get a fair result in the end. Now on the computer, I will get a graph which will show me when there was the incident sound and when there was the reflected sound. Let's actually get that started so that you can see what I'm talking about. So I'll get reading. There's the kind of graph that you get. That is your incident sound, and then that is your reflected sound. So what we have to do is work out the time from the incident sound to the reflected sound. So we take one of the peaks. We can take the peak at the beginning, get the time there, subtract this value from the peak at the beginning of the reflected sound, and so we'll have a lot of time values for you. So we'll keep this one. You have to repeat this a couple of times. So we take the second run. Here we go. Keep that. Take the next one, run 3. We'll keep that one. Take the next one, run 4. We'll do at least 5. We'll keep that one as well. Last run. There's your last run. Now we're going to quickly analyze these results so that we can give you time values.
The length of the tube used was 1,5 meters long. Because the sound travelled twice the distance of the tube, the total distance that the sound travelled was 3 meters. Each time a click was made, the time was measured between each of the sounds, the first sound being the click and the second sound being the echo. This was done 5 times. We can now use the formula distance over time to work out the speed for each of these times. If we take 3 meters and divide it by 0,0086 seconds, we get 348,84 meters per second as the speed. If we repeat this 5 times for every time value, we can then calculate an average speed. This is done by adding all 5 of the speed values and dividing it by 5. Our answer then is 348,04 meters per second. We can conclude from this that this is higher than the expected 343 meters per second, and the possible reasons could be that the temperature of the air was not 20 degrees Celsius, or the fact that perhaps when taking the measurement of the time, an error could have been made.